Hello, this is CyberRyan, and in this video I'm going to walk through Return from HackTheBox, which is an easy level Windows machine that is great practice for some content covered in the CPTS. So if you're practicing or studying for that, I highly recommend you check out this box, and then watching this video after you've tried it. With our machine spawned and IP address known, let's get started. The first thing we're going to want to do is run our nmap scan against all TCP ports. I'm going to save the output in all file formats to nmap TCP detailed, and then run basic scripts and service enumeration, as well as try and determine what the operating system is. This is just my basic go-to nmap scan for starting a box. And after you run that, you should see ports indicating that this is a domain controller. We see that we're on domain return.local, so we're going to want to add that to our etc host file. We see that there's a web server hosted on port 80. Then you've got standard Windows ports like SMB on port 445, WinRM on 5985. And we know that this is likely a domain controller because of the LDAP ports as well as TCP port 53, indicating that this is also a DNS server. So first things first, let's make sure in our etc host file that we have return.local as the IP address of this box. Here we can see we have it in my host file right here. And if we scroll down to the bottom of the nmap scan, we also see that the host name is printer. So I'm also going to add to my host file printer.return.local and printer. And that should be everything for the host file. And since this is a domain controller, we notice at the bottom that our clock skew is off compared to the domain controller. So we're going to want to sync our clocks to the domain controller to perform certain LDAP attacks. So to do that, we need to run this as the root user, time date ctl set ntp off, which is going to set the network time protocol off. And then we're going to want to sync our clocks by using the rdate-n and then the IP address of the box, which is 10.10.11.108. And now our clock is synced to the domain controller. The next thing I like to do is look for anonymous access on any of the SMB shares. So we can do this by using netexec, specifying SMB. We can then use the IP address of the box. Then we can specify guest as our user and a password of nothing, and use -- shares to enumerate the shares. And we see that we get back that it is a Windows 10 or Server 2019 box with the name printer on the domain return.local, but it looks like our guest account is disabled. We could also try to enumerate LDAP anonymously, but I think we're going to have better luck checking out that web server that we discovered. So we can go to our browser and go to return.local. And we see we get a page for a HackTheBox printer admin panel. This fax and troubleshooting tabs don't do anything, but if we go to settings, we have some settings that we can update, including the server address, server port, username, and password. Obviously, trying to copy this password and paste it doesn't give us the actual password of this service printer account, but what we can do is supply our own IP address as the server address and set up a listener using responder to potentially grab the service printer credentials. So to set up this listener, we can run sudo responder and -i to set the interface. In my case, it's going to be ton0, which is the VPN tunnel that connects to HackTheBox, and you can set -v for verbose. And we'll see that what this tool does is set up a bunch of poisoners for different protocols, like local LAN manager, NetBIOS, MDNS, DNS, and it also sets up a bunch of different servers. So we've got an HTTP and HTTPS server set up, SMB, Kerberos, SQL, a bunch of different servers have been set up for all of these services and are listening on these ports, so that if another machine ever tries to connect to us and uses credentials, we'll be able to sniff those out and use them for ourselves. The important one here is that the LDAP server is set on because LDAP is port 389, which is the port that this settings update is going to connect to. And then if we run a simple ifconfig command to figure out what our IP address is on the ton0 interface, we'll see that my IP address is 10.10.14.6. So we can copy that and then go back to our settings page, paste in our IP address into the server address, connect to port 389, which is going to be listened to on responder, and this should send over the service printer credentials once we hit update. If we go back to responder and scroll down, we do see that we've got the clear text username and password for the service-printer account. So we're going to want to make sure that we save these into whatever discovered credentials notes that you have. And then let's see if we can use these credentials to log in over WinRM to the box. If we ignore this warning, we see that we do have a valid set of credentials, and this pwn text means that we can use these credentials to log into the system over WinRM. To actually log in, we can use the tool evilWinRM, and then specify our IP address with the -i flag, set the user with -u, service printer, and set our password to the password that we sniffed, and we get logged in. If we navigate to the desktop, we can list out the directory and see that we have the user flag already. And now that we're actually on the box and we have a valid set of credentials, before I actually start snooping around on the box itself, the first thing I like to do when we're dealing with a domain or a domain controller is to run Bloodhound. So Bloodhound is an Active Directory enumeration tool that finds a bunch of different attack paths or potential attack paths, depending on the Active Directory data that you give it. The first thing we have to do is run a Bloodhound ingester, and in order to do that we need a valid set of credentials, so we're going to use the service printer credentials that we just found. We specify that with -u and -p. We specify the IP address of our machine with the -ns flag. We specify the domain with -d, and in this case return.local, and then use -c all to grab everything in the domain that we could potentially enumerate. And then if you'd like, you can zip up all the files that get generated with the --zip flag. Once that runs, you should see something like this, which is the date at which the scan was run, _bloodhound.zip. Now we actually need to start up Bloodhound so we can ingest this data. To do this, we can run sudo bloodhound and then --no sandbox for some better compatibility. And now with Bloodhound open, we can go to administration and then upload that zip file that we created earlier. So go ahead and click on the zip file and open it up. It's already ingested for me, so I'm just going to go ahead and go to explore. And the first thing I like to do is go to the user that we've got control over. So in this case, service printer. And then we want to right click him and mark as owned, which I've already done. And then over on the right here, we can look at all of the different things that the service printer has control over. In this instance here, we don't have any outbound object control, but we can take a look at what groups our user is a member of. So other than domain users and remote management users, we see that our user is a member of print operators, and most importantly, the server operators group. And if you didn't already know, server operators is a privilege group that we can abuse to escalate our privileges to an administrator. And we can do this by finding a service that is running as system or local system that a member of the server operators group has service all access to, meaning that we can change the binary path of that service, stop the service, and then restart it to do basically anything that we want as that system user. So we could change that binary path to do something like add our user to the local administrators group and then get a shell using psexec. Or we could set the binary path to start a shell using something like netcat or a meterpreter shell, so we get a reverse shell as the system user. Normally to query a list of running services, we could run something like tasklist/service, but in this case here we see we get access denied. And we could also try using the sc.exe binary to find all available services. But once again, we get access denied. The way I discovered what services we have access to on the box was through WinPs, which is a Windows privilege escalation enumeration script. And part of that script checks the Windows registry for services that we have write access to. So let's go ahead and download WinPs to this box to see what services we have access to. Here in my Windows exploitation folder, I have the WinPs any.exe executable. So we're going to start up a web server in this directory. And then back in our evil WinRM session, I'm going to curl WinPs by accessing that web server that we just stood up. And then we can start WinPs like this. As you can see, WinPs generates a ton of output for potential privilege escalation paths. But what we're interested in is this right here, which is looking if you can modify any service registry. And this is going to tell us all of the services that exist on the box. And where it says server operators, write data, create files, generic write, it is telling us that we can modify these services being a part of the server operators group. Now what we want to do is find a service that is running as local system, and we could enumerate these services individually to see which one has authority system permissions. But a good one to check for on domain controllers is the VSS service or volume shadow copy service. And we can find more information about the VSS service real quick by doing an sc.exe qc and then the name of the service or VSS. As you can see here, the display name is volume shadow copy and it is running as local system. I'm going to show two ways that we can abuse this service to gain system privileges against this box. The first, which is the easier but more noisy way, is by modifying the binary path to add our service printer user to the local administrators group. And we can do that by using the sc.exe binary again, then specifying config, the name of the service, and then we're going to set the bind path to Windows System32 cmd.exe, which is just command prompt, specifying the /c flag so that we can run a command within command prompt, and we're going to run net local group administrators service printer /add to add our service printer user to the local administrators group. If you see change service config success, then you know it worked. And now all we have to do is stop and start the VSS service again for this change to take effect. So to stop it, we can do sc.exe stop VSS, and it looks like it's already stopped. So now we can do a start VSS. And it may look like it failed because it says the service did not respond within a timely fashion. But if we do a net local group administrators, we see that the service printer is now a member of the local administrators group. Now back in our attack box, we can use psexec.py to spawn a new shell as NT-authority system by specifying psexec.py, the domain of the domain controller, which is return.local, /service printer, which is now a member of administrators, and then at the IP address of the box. We need to give it the password of the service printer user. And now we have a shell as NT authority system. From here we could go to C users administrator, go to their desktop, and see that the root.txt flag is there, and type it out. Because as NT authority system, you are basically the highest privileges you can have on a Windows machine locally. So that is the fast and easy approach, but probably wouldn't fly in a purple team or penetration test because it is extremely noisy and should get picked up by any blue team. So the better way to do this would be to instead set the binary path to something like a meterpreter shell, and we can generate that meterpreter shell executable by using a tool called MSF-Venom. So let's create that malicious service executable by doing MSF-Venom -P to specify the payload of Windows x64 shell reverse TCP. We're going to want to set our local host or lhost to the IP address of our current attack box, which in my case is 10.10.14.6. And then we're going to want to specify the local port to the port that we're going to be listening on. In this case, I'll set it to 4444. For the file format, we're going to want an exe service executable. If you do just a normal exe, it's going to crash after a few seconds, and then you'd have to migrate to a different process to avoid crashing. So this is just easier to make it a service executable specifically, and then specify the -O flag to name the executable whatever you want. I'm just going to call it shellservice.exe. Once that's done, we can set the binary path for VSS to our shellservice.exe, and then upload that shellservice.exe to the path that we specified. So as you can see here, shellservice.exe is in C user service printer desktop, which is what we set the bind path to. And before we start the service, we're going to want to listen on port 4444, or whichever port you specified up here. And lastly, we do an sc.exe start VSS. We see that the service started, and if we go back to our listener, we now have a shell as NT authority system. So that's going to be the return box. If you enjoyed or found this video useful, please leave a like and subscribe for more security content like this. Leave a comment down below if you have any suggestions, and join my Discord if you haven't already. Thanks for watching, and I'll see you in the next one. See ya.